Tonight we're gonna look at the first, second, and third place DunkTank robots from the 2024 West Coast Products CADathon. We're gonna go pretty fast because we're gonna look at 3 robots, so we're gonna move through them pretty quick because we only have like 20 minutes each. Um, the DunkTank basics, for people who don't know, are basically you just had to score basketballs into 3 heights of goals, and then you had to collect and score a ton of the fuel, like the 2017 little balls. I think they were actually like electrolytes in game, into these dunk tanks. So you could either get them from like the human players, they could dump them in, but there weren't that many, so you ended up needing to floor collect to be able to score more. And the RPs were associated with that as well. So there's a good amount you had to do on 2 different game pieces, 2 different size balls, which is something that we haven't really had in FRC before. So it ended up leaving out some pretty unique robots, and these were the 3 robots that were judged to be the best by the judges of the competition. So we're going to go in reverse order, starting at our third place team, 9032. And we'll look through their submission at what their robot's able to do. Okay, so relatively standard, like we're going to see in most things. They have that standard swerve drive. They did decide to do something a little unique in that they shortened their wheelbase quite a lot to be able to have the intake out on this side, without really changing, without even giving themselves the full width intake, which is an interesting story. So they lost quite a bit of room there. What is that? That's like 6 inches of wheelbase. So that's going to be a little bit less stable, but in this game, you're really not driving around very much at height. It's going to be different than something like 2019, where you had to have your elevator full up, and you were having like defensive robots push into you and things. Here, you're largely going to be protected once you raise your elevator to score. So it is less important to have that fully stable drive base. But this is definitely something you have to consider by pulling this back. This was like on our robot in 2024, we were definitely trying to minimize that distance that we were losing from our wheelbase just because we wanted that more stable platform. So what does that end up actually making their standard drive base? So they're like 26, so that's still pretty okay. So they basically are a 26-inch square-ish. What is this? What does it end up being? Yeah, they're like a 26-inch square drive base with just the intake extending out. So that's still going to be pretty stable. Like a 26 by 26 robot is still pretty stable with corner offset modules and things. You're still going to be pretty good there. And there's probably not much that's going to be hit in here in terms of like frame damage or anything. There's enough of a full frame here with the aluminum and everything to be pretty well protected. Let's see. So other parts of the drivetrain, they did do a brain pan style electronics. So they have most of the electronics mounted down below with, I'm not entirely sure where's their battery. So their battery is going to be here. That looks fine. You should be able to do that power cable and everything pretty easily. And then they would just need to find space, which they have quite a bit of it on this other side too for any of the auxiliary stuff, for like a switch or anything else you would need. Anything like that if you have some extra electronics or anything. There's lots of room down there. Okay, let's move on up because we're short on time. It is a pretty generic, standard slap down style intake. Okay. So yeah, so it's just the Kraken into Max Planetary with a belt to the jack shaft, or there's the hex shaft that's going to cross all the way across the robot so they can power the pivot from both sides. So you get that uniform up and down. And they're using the same or very similar looking motor mounts. I can't tell if those are identical. Maybe that might be identical. To be able to also power rotation, so they do that coaxially. So you get that belt drive here that's going to power through this pivot, right? So this pivot's just going to be on bearings on this shaft, and then you get the power for it coming up this belt here. Oh, and then they do get the kind of the offset bearing support through these bolts that are coming through the plate here. That's not gonna. Is that gonna work? That's a can coder. Is that a bolt inside the can coder? That looks like a bolt inside of a can coder. Yes, it is. All right. So yeah, so that bolt head would need to get probably a jam nut and make sure that bolt's not long enough. You could probably make that work, but that is currently not going to do what you want. But that's probably easy enough to do. You could also make this not a threaded stand or a threaded standoff and put the bolt in the other way, or just move that standoff entirely. You have 3 other ones already. You probably just don't even need this lower one, and you'd be fine. If that just didn't exist, it wouldn't be a problem. Okay, so yeah, so that's really nice in that you don't have to have any motors extend past your frame perimeter. You basically only have that belt, um, and you get a relatively simple, very wide intake that can get your balls up into your elevator to be able to score the basketballs. They did choose to do the full like flex wheel all the way across the shaft. I'm normally not a huge fan of that just because of cost. Each one of these is almost $5 sometimes. They can be a little bit cheaper depending on where you buy them from. But even $3 to $5, you're spending a lot of money on these shafts compared to making some sort of polycarb or aluminum roller with silicone or cat tongue tape or anything else on it, which work about the same. And can normally be replaced easier because trying to like replace anything on this shaft requires lots of taking off the spacers and fidgeting with everything. But it does work. The only other thing I would probably do is because these are live axles, there's no standoffs between here at all. So these plates can kind of pivot in relation to each other a little bit. So having a standoff or two on this edge where the ball doesn't have to come through it probably helps stiffen this up a little bit. Like something like this probably works, but it can twist a little bit more without those standoffs. But they did do a good job of getting that geometry to allow it to package nicely around this intake. So it comes up and over without hitting those wheels in a very nice, clean, stowed position. Programmatically, you'd have to make sure that you just don't raise the elevator where this is in. That's easy enough to do with some state machines and things to make sure this drops down before this raises up. Looking at the balls coming in, it's going to funnel really nicely. So they do all of that funneling on this intake, so they don't have to have any funneling mechanisms or mount anything down here. It's all just on their basketball holder on their carriage. Relatively simple. This 2-plate motor with gears system is kind of the standard horizontal roller claw. We've built versions of this in 2018, and our 23.5 off-season robot did kind of the same thing. And so this is a pretty standard FRC way to build that sort of intake. And with the compliant wheels, it's going to hold tightly, get the ball into a nice position, and then be easy to score it. It's tipped up a little bit to let the ball kind of shoot out and up, give them that extra bit of height, and it would still be able to come in and intake nicely. Ooh, I hadn't noticed that. So the main power switch is not that far away from the battery, but it would be an interesting run to run it up here and then back down to the PDH. Definitely doable, but you're running a little bit longer leads than we would typically like to do. We'd probably try to move it inside further, even though it gets a little bit closer to moving stuff. It keeps those wires shorter. So even like down on this plate or something could totally work. Okay, so let's see if we can't look at their elevator. All right, so isolating their elevator a bit to be able to see that gearbox easier. So it looks like it's a belted elevator. So they have two Krakens driving these gears. So the elevator does get full power from both since they're connected together, but then you get that reverse direction here. Oftentimes now, you don't really need the second motor on the elevator. It can be useful, but especially if we're not climbing, the modern brushless motors have enough to be able to move the elevator pretty quick, especially if you do any sort of counterbalance or anything. Teams have gotten away with a single motor, and that may be a place just to save weight or complexity or cost as well if you need to. Okay. So basically the way this works, I think we looked at we have the video from Jack in the Bot's 2018 robot, and this looks like an elevator pretty similar to that, with the timing belts running up through the tube. So if we look in here, yeah, so this has a very similar construction to that robot where you have the pulleys for the belts to come down, and through each of the tubes doing that way. Then they're just using the standard West Coast Products bearing blocks, the ones with the actual tube inserts that go inside of them with like the end caps kind of built in. So nothing really to see there. And then same with the kind of standard carriage design with those same end caps and a, I don't know what that is. What's happening there? Oh, okay. So that is how they're doing the belt hold down there. That's interesting. Okay. So that is a custom plate they made that mounts into the bearing block and into that tube nut, and then allows them to come through and clamp the belt for their down pull there. Where is... Oh, my mouse is being weird. Where is their up pull? So it doesn't seem like it's being shown in the same way. Does it show up after we take it out of isolate? I don't see it. Oh, is it coming through to get tensioned? Oh, there it is, I think. Yeah, so that's part of the tension block there. Okay, so now if we can isolate that again. Okay, so yeah, so there's their up pull belt. So it's going to wrap around, get bolted into here and clamped, and then they can use this cam to tension the belt in their elevator. So they can basically, as they rotate this cam, this is going to start, it has that cam kind of nautilus shape. So as you rotate it up, it pushes this block higher, and that takes up more of the belt, adding to the belt tension and taking up any slack that gets built while the elevator's in use the entire season. So that should work pretty well there. What are they doing to be able to bolt that in? It doesn't really show what they're doing to bolt that in, but they probably have some version of either the bolt going all the way through the tube and holding on, or some way to put a bigger outside hole to be able to have that something threading into the back of that. You would probably normally want to be able to get into the other side of that and be able to hold it. It's a little tricky to move that cam if you don't have a nut or something on the other side, but they may have a plan for that. If you had holes through all the tubes, you could probably stick a long Allen wrench through. I'm not entirely sure what their plan is there. But again, these are only CADathon robots, so a lot of that stuff gets solved as you're building it if you don't do it during the design. yeah, relatively standard kind of tube nut, or yeah, the nut strip carriage, where you have these nut strips there to be able to mount the whatever the mechanism is. So they have the plates coming down here, mounted to those nut strips. And then they actually use tube nuts as a mounting feature, which is pretty useful. So using tube nuts not in a tube, but kind of using them as a larger nut strip, so you're able to get that like 1 inch thick pattern here. I'm guessing that's what it is. 1 1/8, so a little bit bigger actually. So they put a 3D printed, yeah, they just kind of put a 3D printed block around that. Or did they put a little spacer under it? I think they might have put a spacer under it. Yeah, they did. So they put a little 1/8 inch spacer here. So you have the 1 inch of the tube nut, or the tube insert, the tube end cap, and then they have the 1/8 inch spacer to get the spacing that they actually needed. Yeah, that is a pretty useful, cool use of that block to do that mounting. There's not a lot of other easy ways to do that without either multiple nut strips or custom making a part of some sort. Or you could like put a whole 2x1 here and like cross the whole thing, but then it's harder to get your motors and everything mounted. So that gives you a nice little clean mounting solution. Okay. Let's move on to their fuel. So the fuel mechanism does have an intake, it looks like. So they're going to be intaking their electrolytes up and pushing up on any of the ones above it, which definitely helps. So that's one of the things we kind of can take away from 2017 and know how that works, is they kind of want the balls to be pushing up into the ones above it and being forced up. If you kind of try to force them back into a wall or anything, those mechanisms could jam a lot. That happened a good amount in 2017. And then from there, they get pushed up. This is probably some sort of elastic. Yeah, so they decided to put some surgical tubing here. So as the fuel went up, it couldn't come back out. This right, so it's just it's going to push the surgical tubing away, and so it can't come back out. That's a pretty nice, clever use of that. Just some simple riveted on clamps to hold the tubing there. You could even probably like zip tie something like this if you needed to. You could zip tie multiple strips of it or whatever, and just have ways for the balls to be pushed up and then not come back out. That's a really nice, simple, clever one-way gate for the fuel that doesn't allow them to be ejected back down, only get pushed up. Okay, from there, they need to be able to actually dump the fuel and score it. So how are we doing that? So our guess is there's some form of pivot here that's going to actually allow it to dump. I'm not sure which direction that's going. That's what I thought it was going to do. Okay. So this larger 10 dp gear here is stationary to this rail. The pivot is Max Spline or Spline XL from West Coast Products or Rev. And so that's where you're actually doing all of the sort of heavy lifting here. Did they get a bearing in there, or is there a bearing? Okay, so yeah, so it's just the 3/4 tube probably here. Yeah, so 3/4 tube, and then your needle bearing on the outside in that cage that Rev sells for the Max Spline. So you're able to make that kind of relatively strong pivot here, depending on how you want to do it. It looks like they're doing like a solid 3/4 tube, so they're able to tap that to a 3/8 bolt here. So it's a pretty large bolt. You're not going to have any issues with load or anything on that. And then since the motor's on the inside, it's able to basically drive around this larger gear Sort of the inverse of how our pivot in 2024 worked, but how quite a few other teams' pivots worked. So like the Citrus Circuits pivot and things were the same way, where the gear, the large rack gear, kind of curved rack gear, stays stationary, and your motor and whole mechanism drive around it. And so they're able to pick that all the way up and make it dump. And then they have to have this arc back so that it doesn't actually hit anything when it's going through that motion. And so they're able to not extend farther into their elevator or anything, and still be able to get the full dump motion out of it, like they would need to. So yeah, relatively simple. Again, some use of like nut strips in places to hold things together. They did 2 motors here too. I don't know if that's necessary. You could probably get by with a single Kraken, especially since you can reduce it here. This is going to be a relatively quick rotation, right? This is only a little over 90 degrees. You can gear this down a lot and still have this moving rather fast with quite a bit of torque. And you already have a pretty good reduction on this last stage. So a single motor would work almost certainly there. You do get some redundancy here. If you have the weight, you can do it. Okay, I think that is everything for 9032. So we're going to go ahead and move on to 8040 and see how their robot looks. All right, so 8040 did things pretty similarly again. So you have what looks like custom swerve modules. We don't need to look at those too much, but they do fit kind of nicely in the corner. They have a really wide wheel here. Looks like 2 inches. Oh, 2 and an eighth. So like 2 inches of tread. So you have a really nice wide wheel. Pretty similar looking setup to some of those, but yeah, nothing too crazy in the swerve module. Electronics layout is all just on the belly pan, like most robots. Battery, RoboRio, PDH, VRM or something like that. Yeah, VRM. All totally pretty standard stuff. They did use some like grommets in here, so their wiring, when it passes through these holes, doesn't get cut on any of the metal edges. In general, we try to avoid having these like wire grommet things. We'll use them on occasion when we have tubes, but anytime we can just wire over or around, we will, just because it's a little bit easier to add and take away wires if you don't have to run them through the loop every time, through like the hole every time. There's some designs where you can't really avoid it, so we'll have to do it. It just kind of depends, but a lot of times we'll try to like either lay this flat so it's easier to run wires over, or if we have to, we will run it through. I think we did it in 2022 and it caused some issues, so we try to avoid it now, but it's too bad. You can normally run through it. Just maintenance later on in season gets a little annoying. Main breaker there with the battery there. There's probably pretty good. There's not too much extra room there. You could potentially move it closer to the corner somewhere, so that battery pass is a little bit shorter. Even like putting it up on this rail or something makes it easier to press and makes it closer to the battery. But nothing too bad. Okay. General concept for this robot is we have the elevator in the back, a wrist or arm on it, and the intake for the basketball. Then we have a we have a hopper that runs through the whole length of the robot, but is relatively short in height. So let's look at basketball stuff again first. It's relatively simple. We get a roller here on the exterior with a few flex wheels on it. A 1x1 down here on the bottom with tube inserts or tube end caps, allowing it to act as like a standoff for this whole setup, making it pretty rigid, so it's hard for these to like rotate at all when you have all 4 of these bolts going into it and everything. They can't rotate relative to each other. And another bar here in the back to hold the basketball as it comes in and gets mounted. This is relatively wide, so you shouldn't have too much of a problem with the pilot grabbing it. It's about double basketball width, which should make it relatively easy to score as well, as the rim is quite large compared to the basketball, so you shouldn't have to have too many problems with alignment getting this up there and still being able to lay the basketball in or dunk the basketball. I'm going to go ahead and hide the electrolytes so we can see the elevator and carriage a little bit easier. So they ran a somewhat similar setup to the past robot with the elevator, except they're running what looks like chain, but they do have a belted first stage out to the outside, so they're able to have a single gearbox here with 2 Krakens in it. They then do a good amount of reduction um, and the reversing to be able to have these belts that go out to these main shafts where their sprockets are. So we have chain sprockets here and here. These plates provide a little bit more support so they're not cantilevering that shaft out as far, so they're able to have those standoffs and an extra bearing here. To prevent that, yeah, you do end up with 3 bearings, but they're probably far enough away that they're not binding too badly here. This is relatively short, so sometimes you may not want to have this internal bearing here. It just depends on if you end up seeing higher currents or not. If you get everything straight and everything's running well, it's totally fine. So you can even like run these a little loose first to get this to line up. But this bearing does end up being a little redundant, so you have the one on the outside and the one on the far plate. You don't always have to have that. Um, as things get further away, it's totally fine. As they get closer, it could potentially bind if the bearings aren't perfectly in alignment. But that's easy enough to deal with as you build the robot. Okay, so coming up, they do their chain attachment sideways, so the bearing or the chain is running um, sort of flat to the elevator face. And so to get the bolts going through it, unlike our like 2024 robot that we use the Thrifty Bot chain attachment coming off vertically through it, they have to have another plate that allows the bolts to go through. So this works pretty well. They even add a little clamp plate here, give it a little bit more pressure, so you're not just using the bolt heads or washers or anything. That's a pretty nice setup there. And that plate is bolted, or oh no, it's just riveted straight into the tube, and they just went ahead and CADed their rivets. Okay. Let's see. So this is a cascade setup. So you have a single loop of chain here powering this outer stage, and then the rest of the setup is powered by rope. So you can see the pulleys here and the rope mounts with ratchets here. So they're able to kind of have that rope go over the pulley, get clamped into this stage, and they do the same thing on the far side. So they're pulling up this next stage very evenly because they're pulling up on both sides. And then the carriage itself is done just with this middle rope coming down the middle. So it's still pretty symmetric. You have chains on both sides, ropes on both sides, and then for the last stage, you're able to pull directly in the center. And so that makes it so that your elevator never tries to like pull to any one side or kind of droop or anything. It should all be pretty symmetric and level the whole way through. Um, Up here, they made this plate a little bit thicker, and they did that with the nut strips, which again is a pretty nice way to do that. So you're able to make kind of this 1/2-inch box to allow your sprockets to be held in really easily. You're not having to cantilever anything up here because you get plates on both sides pretty cleanly. Um, because you do have this fully boxed, it's possible these could be thinner if you wanted them to be. They may not need to be full quarter because you're getting some advantage there just with all the standoffs adding some strength. This could be a place where you could also add some sheet metal bends to add some rigidity to and make this a little bit lighter without having to do all of the lightning patterns, but it still definitely works. Up on the next stage, they do it all with some gussets here going in both directions, so not just the side gusset here. They're able to cap it from the top and bolt in as well. That's going to make this whole thing a little bit more rigid, less likely to want to twist at all. They're going to get rid of all of that with this second sheet metal plate up top. And for the actual top, they just have the 2x1 with the tube inserts and tube kind of crush blocks in here as well, so they can bolt into this lower one. So then this ends up just being a 3D printed block. Oop, did that wrong. This ends up just being a 3D printed block with those holes that you can bolt all the way through, so that you don't crush the tube at all. Okay, so the wrist is a sprocket-driven wrist. So they have a Neo here driving down a couple stages of gears, so they can get a lot of reduction before going to a chain and sprocket. And it looks like that is their, what is this? So that's their tensioner. Yeah, so their chain tensioner is built in here. So we have this slot that's running through both these plates, and so they can loosen up this bolt, push it forward, or push it to the left here, and then tighten it back up. And that'll make this chain path be a little bit longer because it'll have to go over that sprocket. And that should allow them to tension pretty well. It is something you have to check on. This could creep a little bit, depending on how you tighten it and everything. But shouldn't be too bad to do. And then they have a 1-to-1 pulley and belt setup into here. So there's a nice, easy way to get a absolute encoder on the wrist. So this sensor right here lets them know exactly where the wrist is in its rotation, no matter where it's powered on or anything. They can have that absolute encoder run to the Spark Max for the Neo, and they can do some pretty easy position control on that wrist. Up here, we get to see the intake powered mechanism. So we looked at the intake, but we didn't see how the actual motor power was working. And so this is a cool little gearbox they've made here to be able to have this belt run that long distance and still be able to keep tension. They're using this turnbuckle, and they have this whole gearbox pivoting on this shaft in here. So this hex shaft right here is holding in this entire gearbox, and so as they tighten this turnbuckle, it's going to tension this belt further back. And the Neo plate, or this Neo 550, is mounted stationary to this opposite plate, but since they're pivoting around the shaft that this one drives, this shaft never moves, only this lower gearbox does. So that lets this just be the tension, and now the motor and this first part of the gearbox is totally fine to be stationary. And that's a really nice, simple, clever way to do this. Similar to 3005's 2023 robot, they had a similar kind of pivoting turnbuckle tensioning message for their arm gearbox. Yeah, and you get this nice clamped metal plate that clamps on top of it and then rivets into it as well to be able to hold the thing. And it ends up being really light here, so it's easy to swing around. So able to intake a basketball on one side, swing around, and get it out the other side. All right, let's look at their electrolyte mech. So coming into here, it looks like they have a way to slide this out. So this is looking pretty similar to 254's intake from 2017. You have the polycarb panels sliding in and out. They're doing it a little bit differently. They're sliding on these rods. Depends on what they are. It's possible they're just like carbon fiber rods, or something along that. 1/2-inch OD. So it's just a 1/2-inch OD rod. It could be carbon fiber. It could be aluminum. I'm Not sure if they have actual linear bearings on this. I think it's just riding on what looks like 3D printed parts. Yeah, that's what it looks like. Oh, maybe not. That might actually be, let's see. So that might be linear bearings inside of there. That would make sense at that size. Yep, so okay, so these are the linear bearings. Quite a few of them. So that's going to be a little heavy. So there's 5 here, and I'm guessing there's 5 on the other side. That's what it looks like. Let me see if I can. We can isolate that. Yeah, there we go. Yeah, so there's quite a few linear bearings in there. That's probably unnecessary. I don't think we've had any of these specific ones on our robots, but I would be surprised if you needed more than 2 on each side. The fuel you're holding a lot of them, so it's going to add up a little bit, but it's not going to be that heavy. And these normally are rated for pretty substantial loads. I know several teams use these in like 2015 to pick up the trash can or pick up the tote stacks and things, and we're able to do it with a pretty limited number of those bearings. But yeah, so they have ball bearings on the inside. Depending on which ones they are, some of them are dry and just have like smooth plastic, but I think these ones have balls. Yeah, you can kind of see them in there. And so they're able to have that rolling friction along that tube, so it's a very smooth motion and easy to move there. Let's start at the bottom. I guess we can see how it's doing that motion. So it looks like there's just a belt here that's running the entire length, and they're going to clamp that to the back of this block, and then power up and down the slide that way. So you're going to have that going on both sides from this gearbox here with a Kraken. They're able to power both sides of that and have it going up and down. And that's going to extend out their fuel intake. Has a Neo 550 here on the edge. That's just belted in gear reduction to a single roller. That's going to pop those balls up and in to this setup. Yeah, so it doesn't extend a floor with it, it doesn't look like. But that should be relatively okay. They're able to get that up and in, and then as they bring this back, it should push any of those balls back inside as well. So they're able to raise this as a secondary motion and not drop any of the ones out the front. They would need to have this closed pretty quick to be able to do that. And then that should let them raise this up. So they have another sort of elevator mechanism here, where it's just that chain from the bottom being powered down here by another Kraken into a simple gearbox, and then up to be able to raise this up and down on this another set of these linear guides that either, oh yeah, so they have the linear bearings in here again. And so you get one on each of these caddy corner poles, and you're able to pick this up. So assuming these are able to stay rigid, which they should be pretty close with mounts down here and things. Ideally, sometimes you would want to have another one of these lifts somewhere to help keep it aligned. This may be something you just have to test to make sure that it can actually go up and down. And then so when it's fully up, they're able to just open up and deposit the balls down into the dunk tanks is what I believe is going to happen. I'm not entirely sure how that works with where the bumpers are and everything. It may just be that they are able to get high enough. But with their bumpers there, you're going to kind of run into the circle. And I'm not sure if I'm missing some way that they're going to be able to get them out and into the dunk tank easily. So they're not spitting them forward at all. They're kind of just spitting them down. I don't know how many are going to always reach there. It seems like a lot will want to fall like on top of their bumper before it ever gets into the dunk tank itself. But But that may be something where you have another like fold-out flap or another extension or something to make that work that just it didn't end up in CAD. There's always ways you can fix problems like that. If for some reason it doesn't work when you actually do the testing. Again, CADathon robots don't get tested, so we never know how well they work. Okay. I think that's everything for this robot. I don't think we missed anything down here. Actually, that's just the way the tube's mounting. So yes, they have a tube nut going into their belly pan and then a 3D printed part surrounding that as well. And that allows them to bolt that into some plates and hold that whole mounting tube for their lift going up into the corner there. And then this one is just mounted up above one of the swerve modules. What's that doing? Okay, so that is interesting. So they bolt a nut strip to the top of the 2x1 and then have plates on both sides to be able to not have it just fully cantilevered off the side of this one plate. They're able to kind of bolt it in as part of that whole stack to give it a little bit more strength. So that whole 3D print kind of nests inside of there. And now this tube is riding inside of this aluminum plate that's going to make it a little bit more rigid and less likely to crack than if it would just had that 3D printed part there. So that ends up with a pretty unique shaped 3D printed part that I imagine would be actually two pieces at some point. So you're actually clamping that tube. So it might be like cut through somewhere in here. So you're putting some force and clamping that in. But they could also just be a single part that you then like epoxy in the tube or something like that as well. Unlikely because it does look like there's a bolt head here. So they're probably bolting it in with a star nut. And you'd want some sort of slit or something cut into it to be able to, like, as you bolt in, you're going to be able to get that clamping force too to hold it in and not just rely on the tension from that lower bolt. But it may work. So there's not a ton of force coming in and out or anything, but clamping normally works really well for a lot of those things. Yeah, so lots of interesting 3D printed parts to be able to hold kind of this mechanism together. And so this is all added in to be able to do the tube and to slide up and down. With some captive nuts, so they have little pockets that they can put the nuts into. And they can bolt right through. Yeah, all right. It's time to move on to our last robot. So we're going to move on to 8033. They were the winners of DunkTank. They also were the PTC winner too, I believe. So that is rather cool. All right. So let's see where to start with them. So we can go ahead and start at their drivetrain. So we have a pretty standard MK4i on one side. So actually it's MK4is on this front side, but because they have the frame cutout and bumper cutout, they're using the MK4N, the narrow. So you still have that inverted modules, but you kind of just shift the motor here over to this other side, which gives you a little bit more room to bring this rail in and support everything there. So you don't gain too much room because otherwise you would just have a motor here, but it does allow you to have this rail nicely placed going across your robot to be able to then mount things like your intake and everything on. Let's see. So yes, they have some swerve protector things in there. And then I did want to kind of see how they were doing their bumpers. So it looks like that's not really their bumpers. That's just more mounting plates for some other tie rod kind of tension members there. Yeah, it looks like bumpers are just mounted with the same sort of 971 2019 plates that Citrus and multiple other teams have started using now. I just have that bumper stud that they tighten in. All right. Electricals seems pretty basic. PDH, mini power module, gyro, battery, RSL. don't see a Rio, but it's probably in here somewhere. That's probably okay. All right, let's look at their basketball mechanism. Relatively kind of standard. Looks like they have a multi-stage elevator. So you have your stationary stage here, and then 1, 2, 3, and the carriage. So you got 4 moving stages for their elevator. Very clean intake, so it comes down. It doesn't extend very far out. It just has these wheels and a nice bar to hold the basketball. So you're going to intake it, kind of run it into the bumper, and hold it into this space. And then you get the wrist mechanism powered just by cracking into a max planetary into this sprocket to be able to actually drive the Spline XL. It looks like Spline XL. Yeah, Spline XL. In addition to a some sort of Spline XL absolute encoder housing of some sort. Yeah, it looks like it's probably custom printed using a can coder board to be able to do that same absolute position that you would do on like a hex shaft, but with this larger spline shaft, and they just gear it. Let's see, we can go behind the bearing. Yeah, so they just have some gears that go on the spline shaft, and then they get that one-to-one motion there that they're able to use to detect everything and know where the wrist is on power up. Okay. The intake motor itself is just done with one of those C spacers. Very common. We use this same thing every year, basically, at some point, where you just space it off the wall so you can run that pulley and belt directly here. And they're only powering one roller, so they don't have much else to do, so it's pretty easy. And then they went ahead and did a kind of Versa axle style mount, it looks like. Let me undo that. So we hide that wheel. Yeah, so is it live? Nope, so it does look like it is a dead axle setup. So the hex shaft itself is bolted into the plate, so this provides that structure. And then they have the pulley here acting as your hub and the place for your bearings to mount. So you get a bearing in the end here. This lets you bolt in your polycarbonate tube, and then the flex wheels are just on top of that and just stretched over the tube itself, and that's what's doing your intaking. So that's a nice simple setup there. For the elevator, we can see what this looks like. So this has that same under elevator drive mounting. They seem to do a little less reduction than some of the other teams we saw, so they just go straight into a single stage, pretty large reduction. We can see what that is. So it's going to be like 11 to 56. So like 5 to 1-ish reduction there, to some printed pulleys with the Thrifty Bot inserts in them. Geared go in opposite directions, and then it looks like they're doing something similar to that 2910 belt drive internal elevator that we've seen a few other teams do as well, where they just get the belts and pulleys coming up and down, and so you have a belt always like running through the gap in each of these stages until it's coming all the way up here, and then it gets to attach into here somewhere, so it's coming down through that hole and probably attaching into here. And they're using that same or similar style of belt tension as we saw earlier when we were looking at it. So they're just able to clamp the belt between these, and then as they turn this cam, it's driving this plate out, and that's giving you the ability to tension either side however you see fit. We do see a limelight here I didn't mention earlier, so that's able to see through and kind of help do, I'm guessing, object tracking on the balls when necessary, and then when the intake's up out of the way. Oop, that did not flip up out of the way. Maybe it'll flip up out of the way. Nope, it just wants to raise the elevator. Okay, well, either way. When the intake's up out of the way, that will let you be able to see up under it. At least mostly. There it goes. All right. Yep, and so this lets you see up under the basketball, and then you can track April tags and things with it as well. What else are we seeing here? So, does cable management get high enough for that? So they don't actually CAD the cable management, but it looks like they do it onto this stage. Is there another cable chain somewhere? So this is, as you do multiple extensions, that is one of the things you have to pay attention to, is how the cable's going to go. Oh, see, yeah, there's one more stage. So there's another cable chain here. So they're basically going to be able to cable chain up this first stage, run the cable over and up the second stage somehow. I'm actually not sure how they decided to CAD this, but you normally end up having a couple different cable runs where you'd either put this, yeah, so it looks like it's probably going to go into this cable chain. So this one would attach here. This would run along, come up this one, back down, and then this one would run up to your actual carriage. And so you're able to get more than double your like starting displacement by doing it that way. So that works pretty well with just those two cable chains, one on each side, and you're still able to get that full range of elevator motion. All right. Let's see. Yeah, all of that's kind of the standard West Coast Products bearing blocks everywhere. Nothing too out of the ordinary. They have some hard stops mounted here, so that stops their stages and provides quite a bit of overlap. So they have a lot of elevator overlap everywhere, so that's going to be really stable. I'm not going to risk binding or anything like that. All right, so let's look at their electrolytes real fast. So what we have here is we have this moving ramp back here on the back that you just saw me move. The intake comes through and is just able to intake fuel, kind of pushing it up that ramp and keeping them out. This would definitely be something you want to test to make sure that it doesn't jam if the fuel gets kind of shoved into the back, as you're not kind of shoving up as much as you're shoving back towards the wall. Some of the 2017 robots were able to make it work. Some of them had more issues as they were jamming. This is less of a flat surface, so there may be some, you're still getting some of that vertical push that kind of gives you more room. Oh, there's the Rio. We had talked about it earlier. Yeah, so Rio's up over on the side there. Let's see. Okay, so looking at this, so they have another one of those simple C standoffs into a single belt reduction on the roller here. Looks like a roller with just silicone or other rubber across the top. Another pulley there to the far one, and then one more with, I assume, a gear. Oh, they actually did a X belt. So this is your kind of like polycord drive, and you can do it in a figure 8. So that's one way to get a reverse if you don't want to have the reversing gears. This works pretty well. You do end up potentially getting some slipping here. If you were to grab this roller, this belt, this type of belt doesn't actually have like teeth, so it can grab on. It can just slip. It does cause quite a bit of friction and things. So it'll want to spin pretty well depending on how tight you make it. So sometimes you'd have to play with the exact length here and like cut and remake some different chords to make this and get it exactly right. But in this application, it should work pretty well to just be getting the balls pushed up and in as they're able to. They do have a pretty wide open top that they're able to kind of dump fuel in the top in. Could potentially get some bouncing around or off because it does have to all come in this opening. That's probably enough room to get most of them, or you could figure out how to have the human player drop them at a somewhat slower rate to make sure they're not going out and over and bouncing off of this. Kind of just depends. Again, you have to test in real life. CADathon only gets you so far. And then to do the actual scoring, they have a movable floor. So they basically are able to raise the floor of their hopper here based on these chains back here in the back. They have a shaft going all the way across with those chains on it, and it's powered down here somewhere. Where's that end up being powered? Yeah, so you got this motor here, and you're powering that block there. And then on the other side, you're just holding it with another bearing block, and you're just holding that sprocket. Since you're doing the power transfer up at the top, since you have a shaft going all the way across, that works totally fine. And then the thing is just mounted to the chain. We can kind of see that. Let me hide the hopper window real fast. And so we can see it mounted to the chain here by the, look like Thrifty Bot elevator mounts. And so they have a few of the West Coast products elevator bearing blocks coming through there. They would have probably had to like machine off the little tabs, it looks like, but that's definitely doable. So these have little tabs to kind of align you to a 2x1. So if they're using them not on a 2x1, they'd probably have to like sand those off or cut them off. But that shouldn't be too difficult to do. Okay, so that's able to raise up. And so that's how you can basically get all of the fuel, even from the very bottom up to the top. But then when they actually want to dump, I'm going to put that back, they have to actually lower this flap. And so the way they do that is they have another motor that's mounted directly across from their intake motor. And it's just powering this shaft that has spools on both ends, and it's able to wind the cord in. And so as that winds the cord in, it's going up over this pulley and here. So that's able to hold this flap closed when it's wound in. And then as they release it and they let out string, it again comes up and over. And this flap wants to fall because they have these torsion springs down here, like you'd find in like a mouse trap, that are always trying to push out the door. These again is a place where you want to do some experimentation. A lot of times you end up needing springs a little bit bigger than this, but it's possible with the door and the fuel and everything, it may just want to open anyway. So that may be enough. And it wouldn't be too hard to package larger springs into there if needed to be able to open that door. So this is just on a simple hinge, and then the door is able to open. All of the fuel can come out, be scored into the dunk tank pretty easily. It's this nice round cutout, so you have that same option for what it actually is when they go over it. So you can imagine very little of the fuel is going to bounce out, because even at the edges, it's able to get all the way in. And then whenever they're finished, they can just close it back up and be ready to drive around intaking more fuel or going to the human player and getting more from there. So this does a good job of using all of that height. They have the wedge here to kind of force the balls forward to make sure they're not going back and over and anything they're not supposed to. So this does a good job of kind of clearing this whole hopper of fuel without anything else. You're relying a little bit on gravity to kind of do the dumping, but as you're pushing up, you're going to get that force from the lift into this wall. It's going to be pushing forward some too, because the balls don't want to be all jamming into this little space, so they're going to want to come out. Okay, I think there's a few other little elevator things, but they're all relatively minor. They just have some aluminum plates here, and they end tap these plates to be able to mount it across, so they have to be able to mill in these holes, which isn't the easiest thing to do. This would be pretty tricky in our manufacturing ability, especially on something this long. You could potentially do it with just like a jig of some sort, so you could like 3D print something or machine something to where you could clamp this into it and just drill it, and try to get these very straight. But ideally, you'd figure out a way to like mount this to a mill somehow, so you could get them exact and be able to drill in and then tap those if we wanted to make a part like that. Yeah, I think that about covers this robot too. Yeah, they use some 3D printed parts to be able to mount their actual hopper, which works well, to the same bar they use to stabilize their elevators, the ones coming down to these two corners. Yeah, overall, very clean. They thought through most everything about how this robot would work. Yeah, it does look, yeah, so it doesn't look like it can score over the back, so it's only able to get to here. So they're almost certainly having to turn around every time they grab a ball from like the line and go back to score it, especially in Aton, but that's definitely doable. All right, I think that wraps up our look at the 3 first, second, and third place winners from DunkTank.